soy milk, protein-rich tofu, edamame. Common thread? They're all soy-based products, and they're all showing up more frequently in American kitchens. But field soybeans, the kind most commonly grown on Ohio farms, are processed into oil. Most vegetable oil is 100% soy. In fact, soy accounts for over 80% of the food oils consumed in the United States. After the oil is extracted, the remaining material is processed into soy meal. The protein-rich soy meal is used as a feedstock. Over 95% of the soybeans grown in the United States eventually end up as livestock feed. Prior to World War II, soybeans were a minor crop. But as early as the 1930s, one of America's soybean pioneers was busily working to develop new soy products. His name? Henry Ford. In the early 1930s, Ford Motor Company spent over $1 million on soybean research. By 1935, every Ford car had soy-based components. Soy oil was used in the automotive paint. It was also used as a fluid in the shock absorbers. Ford even demonstrated auto body panels made of soy-based plastics. During World War II, imports of vegetable oils were drastically reduced. So the United States government promoted a huge expansion of soybean farming. The effort took root. This was what the soybean process looked like in 1952.
We find Mr. Hill harvesting his soybeans with a modern combine like that used for wheat and oats. The combine has done much to make the soybean a popular crop. The beans are cut and threshed all in one operation. When the hopper gets full, the beans are run into a waiting truck. The beans now start on their way to the local grain elevator. From here, they are shipped by train to a processing plant in a nearby city. First, the soybeans are cracked. The cracked beans are fed to these expellers after they have been heated in these steam pipes to about 200 degrees. The cracked soybeans then enter these cylinders and are subjected to a pressure of about 16,000 pounds per square inch. The great pressure, with the help of the high temperature, forces the oil out of the beans. The oil from all the expellers is next forced through this large filter to remove sediment. The crystal clear oil drips out along the side of the filter. In the compressor, the soybean cake emerges at the end of the shaft. Much of this cake goes back to the farm where it makes a fine feed for dairy cattle. Many industrial chemists are working to find new uses for soybean oil and soybean meal. This chemist, Dr. Brother, is striving to improve a process by which the soybean meal is made into a hard and strong plastic. After long and tedious labor in the research laboratory, he may discover new procedures or new products which the engineering chemist can put into large-scale production.
Soybean production has become more modernized and efficient, but the soybean is still processed into soy oil, and the remaining soy meal continues to be our primary feedstock. But what about the industrial uses? With the introduction of petroleum-based synthetics, soy and other bio-based solutions were neglected. But now there's a movement back to bio-based materials, and the soybean once again is in the spotlight.
At Battelle, we believe that plants have the potential to be the chemical factories of the future. And now we're kind of coming back around to re-investigating bio-based materials and using those in replacement of petroleum-based products.
One area where that investigation has paid off is soy toner. Toner is basically the black ink that is used when printing or copying documents.
That black material is held onto the paper by a resin that is traditionally petroleum-based. It actually fuses into the paper and holds into the paper fibers. And when you go to recycle paper, you rip all the paper apart, but you also need to float out and remove all of the print that's in there. And you can then basically reuse that paper and make new white sheet stock again. There's an awful lot of petroleum-based resins that are used in toners, and we were looking at ways to incorporate a bio-based material that could allow the paper to be more easily de-inked.
Their findings? The soy component did allow the ink to be more easily removed.
The soy toner that we developed has been a very successful story, and it's won several prestigious awards, one being the R&D Magazine Top 100 Innovation Award and a Presidential Green Chemistry Challenge Award sponsored by the EPA.
Battelle scientists are busy working on other industrial uses for soybeans.
Soybean oil itself is a good lubricant, and we've been developing a number of different products that have various viscosities with the goal of trying to develop a family of lubricants that can address all of the current lubricant needs, everything from engine oils to greases and waxes. We're definitely very interested in being able to create a bio-based lubricant that can match those performance characteristics of an automotive engine oil.
Early experimenters used soybean oil in paints. Today, researchers have found that bio-based materials like soy can extend the range of applications for powder coating. Many products that had to be traditionally painted with liquid coatings can now be powder coated. Why is that important?
Powder coatings are considered to be a green process because there's very little waste associated with that process, and that they don't use solvents.
Bio-based materials like soy are renewable and sustainable. And at places like Battelle, scientists continue to investigate the potential of soy-based solutions.
In this way, the soybean is transformed by science and technology into parts that find many everyday uses. Thus, the chemist works to find new industrial uses for the products of the farm.